We're going to talk a little bit about the data backbone at PayPal. Couchbase does a lot of work with these guys, and I've worked a lot with this gentleman here. Shibi is from PayPal. He's one of their lead engineers, and my name's Justin Michaels. I'm with Couchbase. So a little bit about the background of Couchbase at PayPal. We'll talk a little bit about some of the challenges they had based on the version, how we solved that, and some things that are changing in Couchbase. And then I'll open up with just a little bit of the business background around to frame the level of kind of scale that we're dealing with when we're working with PayPal. And then I'll hand it to Shibi to dive into the actual Kafka integration a little bit at the end. So the footprint is, there's roughly 7 use cases across PayPal today. They're a variety of sizes as far as the deployments go. And there's 3 data centers that we're talking about. They're all replicating with XDCR. The cluster profile, specifically for the solution that Shibi supports, is around their global cookie service, and that's the 15 nodes with 3 locations, one of them being a DR site. They're all bidirectional. There's roughly a little over 1 billion documents that are supporting the global cookie store. That represents about 3 terabytes of data, and I think the projection over time is roughly about 10 terabytes. The challenge with their current deployment for the cookie service currently is it's running in a 252 cluster. So it comes down to data analytics. And when you look at that version of Couchbase, kind of the things that are available to you when you want to analyze data that's running in a cluster, you can use Couchbase views. They work really well in certain circumstances, but when we're talking about the scale and the level of complexity that we're trying to do with fraud detection in a cookie store, such as in this example, it's not necessarily the best solution. We could use Scoop, but with the multiple locations, then we need a Hadoop cluster in each of those locations, and then there's some complication there. The Scoop integration that we provide is one of the longest running kind of plugins that Couchbase has built. We also have an Elasticsearch plugin as well as Solar. There are other use cases that PayPal uses with Elasticsearch, but ultimately what they were after was more of a streaming integration, and that's where the Kafka connector came into play. So ultimately, the solution that we were able to stand up is a Couchbase server deployment with Hadoop integration that's running across Kafka. And it's not just a point-to-point. Kafka has multiple endpoints that are all streaming across that Kafka cluster. This just happens to be one of those endpoints. The results, some of the SLAs that we're able to meet from a Couchbase perspective, sub-millisecond response times with an application SLA around 10 milliseconds. So these are some of the SLAs that we're able to achieve. Kafka integration for analytics, as well as high availability for distributed cache. Pretty rough idea. So this goes back to some of the challenges of kind of 303 or anything prior, right? This would be a typical Couchbase deployment. I've got 8 nodes. I distribute my data evenly across those nodes, as well as maybe a indexing and query service across those nodes, right? Views are living with the data. Each individual node is maintaining an index for the data that it owns. That's great when it comes to easy scalability, because if I need more capacity, I add another node. The downside is when we're trying to isolate workload and being able to manage a workload and expand a specific workload for query versus key value access, that gets to be more difficult. And that's one of the big things in Couchbase 4, and one of the things I hopefully will work with this gentleman quite a bit more in the future is where can we start doing more query and analytics within the cluster, where the data lives. And that's part of the multi-dimensional scale that's introduced in 4, where you have that same 8-node cluster. Every node is the same, but then it's a matter of what is each of those nodes, what services are each of those nodes performing for the cluster. So here I've taken that same 8-node cluster, isolated 4 nodes. That's still that same key value access with query and indexing isolated in separate areas within that same cluster. Why do we care? Thank you, sir. I appreciate that. If we were in the scenario where we have heavy indexing requirements, you might want more cores would help that, right? So then that's the idea of being able to add additional compute capacity and making that individual node larger than the other nodes in the cluster. So then that indexing service would have additional capacity in order to keep up with the data mutation that's coming into the data services. Similarly, we can linearly scale our query load by adding additional query services that are running inside of that cluster. So if we added another node, we could add additional services that way. And then, of course, we still can simply add another node to the data area in order to be able to linearly scale the data service. So these are some of the capabilities as far as when we're starting to talk about analyzing data that's in a Couchbase cluster, as opposed to only having possibilities of pushing, synchronizing data to other systems and other indexing services, being able to do some of this analytics within the cluster itself. So a little bit about PayPal. They have 165 million active customers. So when we're starting to talk about the cookie service that's deployed, there's a lot of traffic that's coming in and out of this cluster. That data size that we were talking about earlier, it's only growing, and they're in 57 countries. I always think that's an interesting statistic. And in a nutshell, 2015 or 2014 was a good year for these guys. Good year to be at PayPal. So with that, I'll turn it over to Shibi to talk a little bit about the cookie service.
Hello. Hello. Hi. Hello, everyone. My name is Shibi Sudhakaran. I work at PayPal. Thank you, Justin. So as Justin mentioned, we use Couchbase for a variety of use cases at PayPal. I would like to share our experience building these applications that uses Couchbase. I would like to take you through one of the use cases where we use Couchbase, and also want to introduce Couchbase Kafka adapter that we open sourced last year. And Couchbase got interested in this adapter. They released the DCP version of it. So our version works with TCP, TAP. So about the use case itself, it's cookie. Now, as you know, you visit a website, web server drops a cookie to your browser. It's the state information that holds some kind of information about you. The cookie itself is a limited space. It is limited with respect to size, the number of cookies you can have, as well as the content that you can store inside a cookie. PayPal, over the period of last 15 years, has abused that space. We created a lot of cookies. And now we are in the problem of overuse of cookies. Some of our business use cases started failing. Certain use cases started failing because of the payload. Browser would trim after a certain limit. Now we wanted to address that. So the obvious solution for this would be to migrate these cookies to server-side. That way we don't need to change any of the applications. So to kill all the cookies from user browser, we introduced a new cookie. So this new cookie is a bit different from the existing one. It's an indirection to your document at server-side. So all the cookies at your browser gets migrated to server-side. Now your applications can interact with it's a RESTful web service. Call us, and all the cookies get served from the server-side. Now, migrating this to server, we are no longer limited with the limitations of a browser. We are only limited by how much can we horizontally scale this. We can store as much information as we want, as much security information as we want. So there's no more limitations. So to build this solution, ours needed to be a highly available, low latency service, as we don't want to add any more latency to these applications. So we started looking around for a database partner who can help us build the solution. The database that can provide sub-millisecond response time consistently irrespective of the load. We have more than 1 billion documents right now there with Couchbase. The size is over there. And then also the database need to have built-in cache. At the same time, it should be persistent database. The database, the solution needs to be installed cross data centers, at the same time replicate or synchronize among them for eventual consistency. Above all, it needs to fit our use case. Our use case is 50% read and write. So the solution that we want to go with has to be good with both read and write. So that's when we choose Couchbase. And Couchbase has been a great partner with us in building out the solution. Couchbase is built around these 4 core principles: consistent high performance, flexible data model. As you know, it started as a key value pair and later on moved to a document-oriented store. We store everything as JSON documents inside. Easily scalable. We initially started with 10-node cluster. Later, we might increase to 50-node cluster. And always on. So there were patch upgrades happening at the database level, but our application or business was never impacted. So it's always on. So we built this solution. We rolled to production, integrated application, started rolling out cookies, started killing cookies from user browser, and then migrated them to started serving them from the server side. Let me take you through the functional view, how everything stack up. In the top layer, you have customers interacting with PayPal across various channels. And beneath that is frontier where our various applications reside. Like in the last 15 years, we switched our application stack from C++ to Java to Node.js, but we still have all 3. So all these applications interact with CookieServe in the middle tier, and CookieServe talks to data layer. Data layer, we have Couchbase. Using Couchbase, using the SDK, Java SDK. And the bottom layer is where the new ones, Couchbase Kafka adapter, that's the one that we came up with. It looks for mutations in Couchbase. All the changes that's happening in Couchbase. Get those data, push it to Kafka. And from Kafka, we take it to Hadoop, we run our MapReduce job, we analyze this data, and via Kafka, we push it back to Couchbase, and we have a dashboard on top of that, which will help us to analyze this data to make sense out of, like say, if you kill a cookie from user browser, how it is impacting customers. A quick look into our deployment model. The vertical lines indicate separation of different data centers. A cookie service or cluster of servers over there connects to Couchbase server locally. It connects to its logical primary Couchbase cluster. In case of failure, in case it cannot connect, it connects to its logical secondary. And read happened from the logical primary itself. We have bidirectional XDCR to synchronize data for eventual consistency. And unidirectional XDCR for our DR needs, disaster recovery needs. Our cluster overview, right? Looking at our cluster, this is the Couchbase admin dashboard. As you can see, we have more than 1.2 billion records there. Everything sits in memory. Everything sits in memory. That's what. Our ops per second is around 3,000. It's way below than what Couchbase can take. Okay, now we started, as I said, build this application, release to production, but we wanted to measure what kind of impact, how are we improving customer experience, how are we reducing the browser footprint in user browser. So we want to analyze this data. 1.2 billion is sitting there. How do we analyze this data? As Justin mentioned, we have various ways to analyze this data, but we realized that streaming is the way to go, because with streaming, we get all the states of the data, all the mutations that's happening to the records. But if you're running a particular query in Couchbase, you got only the latest record in Couchbase. But we want to know all the mutations that are happening in Couchbase. Moreover, when you stream this data, you can merge this data with other feeds that are coming from other channels and enrich this data for better analytics. So that's when we came up with Couchbase Kafka adapter. Now, Couchbase Kafka adapter is a combination of Couchbase Tab and Kafka. Now, Couchbase Tab, it works with Couchbase less than 3.0. We use 2.5, but 3.0 is DCP. So Tab lets you observe changes that's happening in Couchbase, all the mutations happening in Couchbase. A new record gets created or updates to an existing record or deleting a record. So it lets you observe changes to Couchbase. And then it acts in 2 modes. It can either take a snapshot of the entire database, and then from then on, it can subscribe to various streams from Couchbase. Then we have additional capabilities, like you can have built in your own filtering. So we filter some of our records before we send it to Couchbase, before we send it to Kafka. The Kafka producer part. So Kafka, it's an obvious choice for us. It is the de facto standard right now for data transfer. It is fast, durable, scalable, distributed. highly throughput distributed messaging system I picked up from the Kafka website. But you can configure the Kafka producer to by changing a Kafka config.properties file. If you go to github.com/PayPal Couchbase Kafka, check out this project. There's a properties file. All the configuration that applies for a standard Kafka producer is applied. You can use it to configure the adapter. So that way you can say act as a synchronized mode or async mode. How many machines, how many messages you want to club together as a message set for pushing to Kafka. It's all configurable. So where does it fit in? So from Couchbase, we subscribe to this tab stream, pulls on these messages, pushes to Kafka. And from Hadoop, we pull these messages back using Camas. Camas is another open source contribution from LinkedIn. So one distinct advantage that Kafka is that it is push and pull model, where it doesn't, compared to Flume, where it is push and pull. The consumer decides the frequency in which you want to consume data. And then we run our MapReduce jobs there, use Kafka as the transport vehicle, push the data back to Couchbase, and then our dashboard shows the result of our analytics. Another reason that we want to bring in Couchbase, Kafka. So we feel Couchbase and Kafka fits really well together. So when you send a message to Couchbase, it gets partitioned and goes to one of the 1024 partitions, 1024 V buckets. Kafka, when you create a topic, it gets partitioned to one of the partition in Kafka. So as long as you use the same key, as long as you use the same key, you will be able to map M partitions in Couchbase to N partitions in Kafka. So, and again, Kafka guarantees ordering of records within a partition. So it means that we will be able to get total ordering of the records. Okay, so I'll take you through a simple demo here. Okay, so we have multiple things running, everything in my local computer. This is a recorded demo so that I can fast forward it in case needed. So I have Couchbase running, Couchbase workload generator, Kafka server, Couchbase Kafka adapter, and the right-hand side we have Kafka consumer. What I'm trying to do here is Kafka load generator, the second window, the black one, is trying to push 1 million messages to Couchbase. It is pushing messages to the default bucket. And the third window over here, the blue one, is Couchbase Kafka adapter, pulls these messages from default bucket, push it to Kafka server, and from there, the right-hand side is the Kafka consumer, consumes these messages, push it back to Couchbase into a replica bucket. So we are taking a replica of a bucket from Couchbase into the replica bucket. So initially, it will take some time to catch up, as Kafka producer would like to buffer some messages before it for optimization, network optimization reasons, and before you push to Kafka. So here it's like, let me fast forward a little bit. So 400K, 400K, it's almost neck to neck right now. Let me forward towards the end and I let it run. It's 95240 and it refreshed. So basically the idea is to, it's almost neck to neck. At this point, it's like 1,000 records difference between these two, and 1 million record at the default bucket got replicated 1 million over there. Okay. So for our monitoring purposes, we have our own tool within PayPal. We send heartbeats to our tool. It's called Sherlock. It conflicts with Couchbase new release version Sherlock. But this is what we have in PayPal. We send our heartbeats to over there, and if it goes down, that's how we monitor. And then thank you again. My name is Shibi. My Twitter handle is there. You can reach out to us. We are open for questions.
If there's no questions, we appreciate it. Come find us afterwards and enjoy the rest of the day.
And you can reach us in this. We'll reply. Thank you.